So let's begin with number 2. All right, so the equation x squared plus x equals 6x has distinct real roots. Find the range of values of x. Now, class, I have highlighted some keywords here that are very important. When you say two distinct real roots, that means that your discriminant is greater than 0, or it's a positive in other words. Okay, two distinct real roots. If you're not familiar yet, we can go back to the previous table here. Okay, so this one, two distinct roots. So your discriminant is greater than 0. So this is what we're going to use for that. That's your, um, let's say, keyword for this one. All right, and then it says here, the question is, find the range of values of k. If it's asking for a range of values, that means that you have a lot of answers. That means it's an inequality. Inequality is greater than, less than, right? Or maybe greater than or equal to. It depends on this. Now, since this is two distinct real roots, our inequality is this one, greater than 0. So that's what we're going to do. All right, so for number 2, we're given this quadratic equation. You need to change this first to the standard form. Okay, so this is the standard form. I'm writing my steps here so you guys are guided properly. So what did I do here? So basically, I transpose 6x to the left side. I got negative 6x, and then um, this is supposed to be positive k, not negative k. All right, that one. All right, all right. So that's equal to 0. All right, so that's the standard form. And then from here, identify A, B, and C. Now, class, starting on this topic, now you might be wondering, why is C equal to K? All right, if that's the case, that means K is your missing variable. That's part of the question. That's here, right? Okay. Anyway, A is 1, B is negative 6, and C is equal to K, right? And then, what do we do next? If it's talking about real roots or roots, we need to use the discriminant, this one, right? So we need to use that one. It says two distinct roots. So discriminant is greater than 0, all right? It's because of this. Now, other questions. What if it says equal roots? All right, what will be our discriminant? Your discriminant will now become equal to 0. Those are the keywords, class, all right? And if it says no real roots, it will become less than 0. All right. Anyway, that's it for, we will have some questions that has something like that. All right. Anyway, so this is your discriminant greater than 0, right? And then you just plug in A, B, and C here. So B squared is negative 6 squared minus 4 times A is 1. And then C is what? C is K. So that's why this is K. And then greater than 0. All right. And then what you need to do is to solve for K, right? So I think you guys know how to solve inequalities. Solving inequalities is just like solving equalities or equations. All right. So 36. So this is now a negative 4k. If you're after for the values of k, of course you transpose it here. It becomes minus 36. Get rid of negative 4. And then k is less than 9. Why do you think k is less than 9? It was greater than before. Now it became less than. Why do you think? What's the what did we do here? Hmm? It's because we divided an inequality by a negative number or negative integer. Remember that, right? When you were in sec 2, right? When you divide uh, by a negative integer, the inequality reverses to the other side. Okay, that's why it's now k is less than 9. So the range of values of k are all numbers less than 9. So that's your answer for number 2. Okay, only that. All right, let's go to number 3. If the equation 2x times p minus x equals 3 has real and equal roots, find the exact values of p. All right, so what are the keywords here? real and equal roots. All right, so that means that your discriminant is equal to 0, right? And then exact value, that means that's an equation, equals. Okay, but your clue, values, that means there are 2. All right, so that's it for number 3, and then let's solve this now. So we're given this equation. So of course, this is not yet in standard form. So how do we change this to standard form? So write it again. Distribute this. So you'll get 2px minus 2x squared, and then rearrange this to the standard form. So obviously, the x squared goes in front here, and then bring down 2px, and then transpose 3 to the left side. It becomes minus 3 equals 0. So that's what happened. And then from here, it's already in standard form, so you can identify A, B, and C. Now, A is 2, B is 2P. Take note, class, 2P, not only 2. Common mistake here is that some students, they think that, oh, it's 2. No, it's 2P. All right, any number or variable except X is part of your A, B, or C. Okay, so any variable, if it's 2P, it's 2P. All right, if it's, let's say, 2ABC, your B is 2ABC over here. Okay, except X. Okay, everything here except X. So that's 2P. And then C is negative 3. All right, so we have ABC. So let's now use our discriminant, B squared minus 4AC, and it's equal to 0 because, again, it has real and equal roots. Okay, now from here, so just substitute all the values of ABC. So B squared is 2P. So 2P squared minus 4 times negative 2 times negative 3, and that equals 0. Let's simplify. So this is 4P squared, and then this one is a negative 24, right? Negative 24 equals 0. And then the question here is exact, you need to find the exact values of P. So that means that you need to solve for the values of P. Since this is quadratic, you will get 2 answers, right? So transpose 24 here becomes positive 24. Get rid of 4 by dividing both sides by 4. That's why this is now 6, right? And then how do we get rid of the square? We get the root of both sides. So it cancels out the P. So P is equal to positive or negative square root of 6. Okay, so that's your answer for number 3. Okay, any questions, class? Any specific questions before we go to the last question from your homework? None? Nothing? All right. By the way, class, we have extra class after this one at 2:30 up to 3. Okay, so please join. All right, now let's go to number 5. So this is the last question from your homework. Okay, this might be the trickiest of all. All right, now for number 5, it says here, find the range of values of m such that the roots of the equation mx squared plus x equals x times x plus 3 are not real. All right, so again, what are your keywords here? Range of values, that means that's inequality, right? And then what does it mean when your roots are not real? If your roots are not real, that means that your discriminant b squared minus 4ac is less than 0. Okay, that's what it means. All right, if the roots are not real, your discriminant is less than 0. So it's an inequality. Okay, and then this is your equation. All right, so first things first, obviously this is not yet in standard form, so we are going to change this into the standard form. All right, now let we begin from here. So write it again, and then we simplify this, remove the brackets. So this one, so you'll get x squared plus 3x. All right, and then what's next? Basically in standard form, everything is on one side equals 0. So that's what we need to do. Put everything here So x squared becomes minus x squared, and 3x becomes minus 3x equals 0. All right, so what's next after this? Okay, now for this one, you need to factorize this one. All right, so mx squared minus x squared. So you need to factorize this because since both of them has x squared, that means your common factor here is x squared. That's why x squared is in front. All right, and then divide mx squared divided by x squared, we'll get m. All right, and then minus x squared divided by x squared is minus 1. That's how I got m minus 1 here. All right, and then m minus 1 is your constant. This is your coefficient, sorry. This is your coefficient. This is a number. All right, so this will be your a. Okay, and then of course b and c is this too. All right, now class, just want to um, emphasize on this one. All right, now you can put m minus 1 in front of x squared. Okay, I know when we factorize this kind of expressions, I know that let's say that the answers usually are after the common factor, right? It's always behind or it's on the right side. On this one, of course, multiplication is commutative. That means it doesn't matter, or the arrangement doesn't matter. You will still get the correct answer. So you can put m minus 1 in front of x squared like this. All right. Okay. Because you guys are, I know you guys are used to the standard form, which is ax squared plus bx plus c. So a is m minus 1. All right. But if it's here, it's still the a. All right. But for this one, this is a. M minus 1 is your a. Okay. And then your b is negative 3. And then your c is equal to 2. All right, so that's how we got the A, B, and C from here. Because what we're after here, again, is the range of values of M. That's why we have M minus 1 for our letter A. Okay, so what's next? Okay, so we use the discriminant less than 0. So you plug in A, B, and C here. So you get negative 3 squared minus 4 times M minus 1 times 2 less than 0. So evaluate this. So this is 9. And this is 8m minus 1, or 8 times m minus 1. So 4 times 2 is 8, and then m minus 1. And then remove the bracket. So this, multiply it here, you get 8m plus 8 less than 0. So if you're solving for m, bring down negative 8m, add this 2, you'll get 17, right? Then put them here, you get negative 17. And then, of course, you get rid of negative 8 by dividing both sides by negative 8. And by doing so, your inequality will reverse. From less than, it becomes greater than, right? And then your final answer is 17 over 8, or positive 17 over 8. All right, so for number 5, your answer is m is greater than 17 over 8. So the range of values of m are numbers greater than 17 over 8. Okay, so do you have any other questions for number 2, 3, and 5? Any specific questions? All right, so if you don't have any questions later in the extra class, you might ask me a few. All right, so that's your homework, 2, 3, and 5. All right. Okay, so before we go to the last topic for this chapter, chapter 4, okay, I'm going to have one more example, all right, which is much trickier compared to your homework. So please listen carefully, class. So this is example number 12. You'll find this in your textbook. It's on page 73. All right, page 73. Okay, so right. Okay, so let's go to example number 12. Now, last Tuesday, I told you guys that the graph of those discriminants, okay, right? Wherein if your discriminant is greater than 0 or positive, that means that your curve intersects the x-axis at 2 points, right? And then if your discriminant is equal to 0, that means that your graph or the curve intersects the x-axis at only 1 point, right? And then also, if your discriminant is less than 0 or a negative, that means that the curve didn't even touch the x-axis, right? So in here, we are going to talk about curves and lines, all right? So let's have number 12. If the line y is equal to mx minus 8 meets the curve y is equal to x squared minus 5x plus m, right? So that means basically, class, you have two graphs here, a line and a curve like this. All right, so it says there that they met. All right, and then they said, okay, but we don't know if it's 2 points or if it's just 1 point, because what it showed us is this one. Okay, if it's greater than or equal to 0, it means with real roots. Now we don't know if it's positive or equal to 0. All right, so that's what we're going to find out for this example. Okay, so basically, class, you have two equations here, right? That we can solve simultaneously, if you still remember your simultaneous equations. So these are your two equations, your first and second equation. So since both of them are equal to y, so we can just make them equal to one another. So that's what I did. So x squared, because y is equal to y, right? So this one, so x squared minus 5x plus m equals this one, mx minus 8. All right? Okay, so that's it. Because since they are both equal to y, so they are also equal to each other. All right. Now, maybe you're wondering, why did I put this in front rather than this one? It's because I just want to make my x squared positive. If I put it here, there's a big chance that I will have a negative x squared. And then that's why. But you can still do that, all right? So this is my equation. All right, so what's after that? You just need to change this to standard form, okay? So I forgot to do that, so change in standard form. Okay, so again, the standard form is ax squared plus bx plus c. So basically putting everything to the left side, right? So that's why this is now minus mx, and this is now plus 8 equals 0. All right. All right, so, and then what's after this? Okay, so x squared is just x squared. It doesn't have any pair, so bring down x squared. However, look at this one. Okay, so you have this. So both of them has x, right? So you should factorize this two right here. And then their common factor is x. All right, that's why we have our common factor x. And then divide each of this by negative x. So negative 5x divided by negative x is 5. And the negative mx divided by x is simply m. You get rid of x, right? So this is the factored form of this one. Okay, and then you bring down m plus 8 since they don't have any pair. Okay, now why did I do that? Because um, this is your b, basically, class. This is your b, or the value of b. Just like from our previous example, you can also put this in front of x, just like what I did here. That's why I have or. Okay, it doesn't matter. This is your b. Okay, this is your b. And then the m plus 8, this is your c, this is your constant. Okay, because if you're going to pattern this with the standard form, this is ax squared, sorry, let me put ax squared plus b x, right? So this is your b, and then plus c. So c is everything without any x. All right, if it's m plus 8, c is your m plus 8, because it, but if it turns out to be mx, you should put this with this. Okay, so that's the point of having the constant. So constant is every number here or every variable without x or x squared. Okay, so if it's, let's say, m plus n plus 8, so this is your c. Okay, because they don't have x. If it's, but if it's mx plus 8, c is not part of this one. Okay, or mx will not be part of c. All right, anyway, this is your equation, this is your standard form, right? And then identify a, this is a is 1, b is 5 plus m, and then c is m plus 8. So that's it. All right. Okay, so after that, we are going to use our discriminant, right? So the discriminant is that it's because it says here that we need to show that m squared plus 6m minus 7 is greater than or equal to 0. All right, so that's what we did. Now, in order for you to solve this, obviously you need the a, b, and c from here, and then put them all here. All right, and then of course, so we got 5 plus m squared minus 4 times 1 times m plus 8 is greater than or equal to 0. So you basically expand. So you get this from here. Okay, so 25 plus 10m plus m squared. So again, it's 5 plus m times 5 plus m. And then this one, obviously, it's negative 4. Negative 4 times m is negative 4m, and then negative 4 times 8 is negative 32, greater than or equal to 0. So yeah, that's it. So after you have simplified this, it's now this one. So we have shown that this two will become this one. All right. Okay. So that's it. So we have shown that. But the question here, class, is now how do we answer this kind of question? How do we solve for the inequality? Because if this is equal to 0, there will be like m minus 7 and then m plus 1, right, equals to 0. But what if it's an inequality, right? So that will be, all right, this is part of the last topic on chapter 4. We're in, okay, how do we solve quadratic inequalities, right? Now, from my previous example, all right, so let's say we have, let's say, factored out the answers there. So let's say we have x minus 1 times x minus 4 is equal to 0. Okay. All right, this one. So of course, it came from this one, x squared, so x squared minus 5x plus 4, and then less than 0. So when you factorize this, you'll get this one. X minus 1 times x minus 4 is less than 0. But how do we solve this kind of questions, right? So how do we solve quadratic inequalities? Now, as you guys can see, I have here a graph to represent the range of answers or range of solutions for this one. Okay. Now, for example, obviously this is less than 0, right? So that means that your y is less than 0, because this is your y. And then for the second one, okay, if this is greater than 0, or your y is greater than 0, it's another set of answers. Okay, so take note, class. If your y is less than 0, in this case, x minus 1 times x minus 4 is equal to 0, that means that your y is negative, right? Everything less than 0 are negative. So when you graph your curve, okay, the solutions only lie on the negative side of the y-axis. You see the yellow highlight? So your solutions will only cover from here up to here, all right? Because your inequality is less than 0, all right? However, if it's greater than 0, we should shade this part right here. This is, yeah, these are all the parts of your solution, or these are all the solutions if it's greater than 0. Right? Maybe you're asking, why is it up and then why is it below here? Because again, these are all positive y, and then these are all the negative numbers, right? That's why this is your border, above the line, the x axis. Okay, so what time is it? It's 2:03. All right, so anyway, let's have some examples. All right, now can you please go to page okay, page 75. All right, so let's have one example that involves quadratic inequalities. Now, find the range of values of x for which 2x squared is less than 5x plus 3. Okay, so how do we find the range of values? Um, for this example here, class, you don't have to graph this question. We are only graphing this because, we just want to show you guys how it looks like on the x and y plane. Okay, so basically, this is the quadratic equation. So this is not yet in standard form, so we need to change this in standard form. So you need to put this on the left side. It becomes minus 5x minus 3 less than 0. Okay, and then what do we need to do next? Okay, so you need to factorize this. All right, you need to factorize this. So you factorize this by guess and check. All right, so this is the guess and check factorization that I did. So this is okay. So you guess and check. What are the factors of 2x squared? It's 2x and x. So this 2. And then what are the possible factors of negative 3? It's either negative 3, 1 or 3 and negative 1, right? So my correct pair is this, positive 1 and negative 3. So you do guess and check by checking this. So, and then when you add this, when you add the product of this one should be equal to the middle term, right? So if that's the case, that means that our factors are correct. Okay, so that's how I got 2x plus 1 times x minus 3 less than 0. All right, so anyway, so after that, so basically, um, write each expression less than 0. So 2x plus 1 less than 0 here, and then x minus 3 less than 0 here, right? So solving for x, so x will be negative 1 half, and then solving for x here, x will be less than 3. That's it. That's your answers. So your answers are 1 half and 3. Okay, that means that the x values are bounded by these two numbers. Okay, so x, you can, because you can also write it this way. So x is only from negative 1 half up to 3. So you can also write your answer like this. That means that these are the boundaries of your answers. All right, that's why you have this curve, and then you have this negative 1 half, and then this 3 here. And then take note, class, that y is less than 0. Okay, if y is less than 0, that means okay, the range of solutions are only here, It's below the x-axis. That's why I highlighted this in yellow, right? So that's it. Okay, but you don't have to sketch the graph, just this one. All right. All right. Let's have one more example. Okay, example number 14. All right. So find the set of values of m for which the equation 2x squared minus mx plus 2 equals 0 has real roots. All right. So you see this word again, real roots. Okay. So what do we mean by real roots? When you see the word real roots, okay, b squared minus 4ac is greater than or equal to 0. right? Real roots. Because if it says real roots, we don't know if it's positive or equal to 0. That's why it's this inequality right here. Okay. So anyway, for our last example, let's answer this now. So there's a set of values of m, wherein we're given this equation. So basically, we need to know, is this already in standard form? Yes, it is. So we can find a, and then b is negative m, and c is positive 2. So that's it. Okay, and then we use the inequality or the discriminant, okay, from here. So b squared minus 4ac is greater than or equal to 0. And then you substitute a, b, and c here. So you'll get this one. So negative m squared minus 4 times 2 times 2 greater than or equal to 0. And then solve for m. So you get m equals, sorry, m squared minus 16 greater than or equal to 0. And then so if you're solving for m, you transpose it here, it becomes positive 16. And then to get rid of the square, of course, get the square root of both sides. So therefore, m is greater than or equal to positive or negative 4. All right, m is greater than or equal to positive 4. That means here, class, that y is greater than 0. Because look at your answer. It's greater than or equal to positive or negative 4. So basically, this whole equation is greater than 0. Okay, so that's it. So that's the boundary of this one. So these are parts of the solution. Is everything from here to here is not, I mean, will not satisfy the equation. So here and here. Anyway, if it's asking for the roots, you just give them this. You don't have to show the graph. All right. So just this one. Okay. So let's have number 1, letter B, and letter C. So in this question here, we need to find the solution set of each of the following quadratic inequalities. So given letter B, which is x times x minus 2 is less than 3. All right, so here's my answer for letter B. So for this one, this is simply x is less than 3, and then x minus 2 is less than 3. All right, so solving this, you'll get x is less than 5. So your answer so the solution set for letter B are values from 3 to 5. All right, so these are your answers for letter B. Okay, for letter B, you don't have to expand this like x squared minus 2x and then minus 3 because it will just go back to these answers. All right, so that's letter B. Now for letter C, so we are given x squared plus 5x minus 6 is less than 0. So how do you factorize this again? If you're given a trinomial or something like this. So again, product of negative 6, sum of positive 5. Okay, so we can use that because x squared here is just x squared. If x squared here has a number with it, like 3x squared, we cannot do that. We need to guess and check. However, if it's just x squared or a is equal to 1, we can do something like that. So that's the shortcut. So product of this and then sum of this. So what are the factors of negative 6 that when we add them, it's equal to positive 5? Of course, it's 6 and negative 1. So 6 times negative 1 is negative 6. 6 minus 1 is 5. Okay, so that means we have the correct factors less than 0. What's next? So not equate because it's an inequality. So x plus 6 is less than 0. So write it 1 there. And then x minus 1 is less than 0. So for this, so the solution set for letter C is from negative 6 up to positive 1. All right. So this one. Okay. So that's your answer here. Okay, if you have the curve, it will start from -6, and then this is +1. So these are your solutions, everything here. Okay. And then, did you guys do letter H? So letter H, of course, it involves more steps than B and C. Now for letter H, we are given x plus 2 times x plus 3 is less than or equal to x plus 6. All right, so first things first, you need to remove the brackets. Okay, so you need to multiply this, and you'll get x squared plus 5x plus 6. Okay, and then bring down this. Okay, and then what's next? So obviously, you need to change this to the standard form. So you need to transpose x plus 6 to the left side. So bring down this one. So x becomes negative x, 6 becomes -6. So what do you notice, class? So you're left with x squared, and then this is 4x, and then this is 0, right? So you're with x squared plus 4x is less than or equal to 0. To solve for the values of x, or for the solution set of x, what you can do here is just factorize x. All right, so x is the common factor, so we put x here in front, and then divide each of this term by x. So x squared divided by x is x, of course. 4x divided by x is 4. And then less than or equal to 0. Okay, and then what's next? So just like what we did on letter B, so x is less than or equal to 0. So your first is 0. And then x plus 4 is less than or equal to 0. So, okay, so the solution set here is from 0 to -4, or -4 to 0. Okay, so that's it for letter H. Okay.